Hi, this is Bradley Bush. Let's talk about limits that involve infinity. Specifically, let's talk about this one. The limit as x approaches infinity of 1 over x to the n, where n is a positive integer. So what exactly does that mean? X approaches infinity. Infinity isn't actually a number. Infinity is a concept that means increasing without bound. So really what we're saying is, as x gets bigger and bigger and bigger and never stops, what is the behavior of a specific function, say 1 over x squared, or 1 over x cubed, 1 over x to the third? What does the behavior of the function do? And we know that as the denominator goes up, the whole quantity itself goes down. And in the end, we have 0. If the top stays 1, the numerator of the fraction stays 1, and the denominator blows up and keeps getting bigger, the whole quantity itself is going to go to 0. So we're going to use that, actually. We're going to use this information in our problem. So what if our problem is this? Find the limit as x approaches infinity of the quantity 3x squared minus 1 divided by the square root of 16x to the fourth plus 1. Now, oftentimes when we take a limit like this and we let x go to infinity, one trick that's helpful to us algebraically is to divide the top and bottom of the fraction by the highest power of x that we see. So if we're looking for the highest power of x, in our case, it's x squared. You might wonder, why isn't it x to the fourth? Because I see a 4 there. 4 is obviously bigger than 2. But we can't forget that this one right here is actually inside of a square root. And the square root of x to the fourth is really x squared. So the x to the fourth in the denominator right here is really an x squared once we take the square root. So x squared is actually our highest power. So what we're going to do is we're going to divide everything in the top and bottom by x squared. Or in other words, here I multiplied by 1 over x squared in the top and in the bottom. We can see that we have x squared in the bottom here. And here we have x to the fourth. Now, if you're wondering how we got from this spot to this spot, we'll talk about that right now. Well, here's our starting spot. 1 over x squared multiplied by the radical 16x to the fourth plus 1. So if we remember that x, the square root of x to the fourth is the same thing as x squared, then we know that this x squared is actually the same thing as the square root of x to the fourth, at least for positive x. So why don't we just replace it? So that's what we do. We plug in, instead of x squared, we plug in the square root of x to the fourth. We can use our exponent rules and expand this radical to the entire fraction, because the square root of 1 is just 1. So we put it all underneath the fraction. And then once we have a radical times another radical, their indices are the same. Our rules for radicals say that we can combine them into one radical. And that's what we do here. Once they're combined into one radical, we just distribute. That brings us back to where we were right there. So if we continue from above, then We can see right here we have some cancellations. We also have some cancellations there in the bottom. We can take the limit of the numerator and the denominator separately because of the laws of limits. The limit of 3 is just 3 because the limit of a constant is just a constant. And the limit of 1 over x squared is going to be 0 from this rule right here. In the denominator, we can actually take this limit inside of the radical, just like you see right here. Once we take the limit inside of the radical, the limit of 16 is 16. The limit of 1 over x to the 4th, again, is 0. And that gives us 3 over root 16, which gives us our answer, which is 3 over 4. So in summary, the limit as x approaches infinity of 3x squared minus 1 over radical 16x to the 4th plus 1 is just 3 over 4. That's it. Thanks for watching. If you'd like, leave a comment and like the video. Thanks.